Hello friends, welcome to UGPG Mathematics. The next question, G is equal to Z100, then the number of elements of order 50 in this group G is, first is 20, the second option is 25, third is 30, last is 50. Now for this question, just note the important result which says that if G is cyclic group and if n divides any some number which divides order of G, then there exists a unique cyclic subgroup, say H of G, such that order of H is equal to n. ठीक है, मतलब अगर आपके पास कोई भी साइक्लिक ग्रुप है and suppose some n number divides that order of G, then there exists a unique cyclic subgroup H of G such that that order of H is equal to n. मतलब कोई भी आप डिवाइजर लो order of G का, there exists a subgroup of order this order. ठीक है, and here this is denoted by H. Or moreover, this is unique and it is cyclic because every subgroup of a cyclic group is cyclic. तो आपके पास कोई भी सबग्रुप रहने दो साइक्लिक ग्रुप का, वो हमेशा साइक्लिक ही होगा. ठीक है, अब देखो, अब हमें क्या बोला है कि एलिमेंट्स ऑफ ऑर्डर 50 फाइंड आउट करने हैं. सो फॉर दैट टेक दैट G टू बी दिस. नाउ this 50 divides 100, right? 50 into 2 is 100, so 50 divides 100. So by this previous result we have there exists a unique cyclic subgroups H such that order of H is equal to 50, right? And moreover this like it is unique है ना. तो आपको क्या करना है, ऑर्डर 50 के एलिमेंट्स फाइंड आउट करने हैं. अभी देखो ये सब ग्रुप का ऑर्डर 50 है, तो आपने अगर जो ये ऑर्डर को जो कोप्राइम एलिमेंट्स है वो अगर फाइंड आउट कर लिए तो ये उसके क्या हो जाएंगे, जनरेटर्स हो जाएंगे, तो उनका भी ऑर्डर 50 हो जाएगा. तो उसके लिए आप क्या करो, यू जस्ट फाइंड आउट द नंबर ऑफ जनरेटर्स इन H which we can find out this by taking the order of, so phi of 50, that is phi of this order of H and which is 50. So phi of 50 मतलब ये जो ऑयलर्स फंक्शन है, आप वो 50 के ऊपर ऑयलर्स फंक्शन देखो तो वो क्या हो जाएगा. नाउ यू कैन राइट दिस 50 एज 2 into 5 square, right? So phi of 50 is just equal to 50 into 1 by 2 into this is 4 by 5, right? So this is just equal to 20. So this is just, so this gives us there are 20 elements of order 50 in the group G. So this first option is the correct option. Now let us solve the next question. How many proper subgroups does the group Z direct sum Z have? So just note that this Z is a group and every subgroup of Z is of the form MZ. ठीक है, that is it is generated by the element MZ. For example 2Z is generated by the number 2, ठीक है, or -2. That means you take all multiples of 2. For example 3Z is just subgroup generated by the element 3 and so on. So MZ is generated by M. Now Z has this subgroups and for this Z suppose it is NZ, right? So all the subgroups of this group is just of the form MZ direct sum with NZ, right? And this M and N need not be same. ठीक है, तो मतलब यहाँ पे 2Z हो सकता है, उसका डायरेक्ट सम विथ 3Z भी हो सकता है ना. तो there are different possibilities for M and there are different possibilities for N and this M and N are integers, है ना. So this, there are so many possibilities, right? Infinitely many possibilities, because this Z is infinite. So there are infinitely many proper subgroups for this Z direct sum Z group. So this D option is the correct option. Now let us solve the next question. What is the last digit of this number 97 raised to 2018? Last digit कैसे find out करते हैं? So whenever you have, suppose this is our number, तो आप क्या करो, 97 raised to 2018 is congruent to this number, what, modulo 10. ठीक है, यहाँ पे लास्ट डिजिट मतलब आपको मॉडुलो 10 लेना है. सो मतलब बेसिकली आपको रिमाइंडर फाइंड आउट करना है व्हेनेवर यू डिवाइड दिस नंबर बाय 10. ठीक है, then that number will be the last digit of this 97 raised to 2018. So here we will use the Euler's theorem. So it says that a raised to phi of n is congruent to 1 mod n if that GCD of a and n is 1. That means they are co-prime. ठीक है, now let us take a to be 97. So this gives 97 raised, and we know that we want this modulo 10, right? So mod 10 is 1. Now you take, now this is phi of n. So here n is 10. So phi of 10. What is phi of 10? This is just equal to, you write first 10 as prime factorization. So it is 2 into 5. So phi of 10 is just 10 into 1 by 2 into 4 by 5. So this is just 4, right? So we have 97 raised to 4 is congruent to 1 mod 10. Up till this is clear, right? Now we have, so 97 raised to 4 is congruent to 1 mod 10. Now we want this 2018, right? But we just have this 4. So let us write 2018 as, you somehow write these numbers into the multiples of 4. Now 2016 is a multiple of 4, right? Plus 2, right? So 16 plus 2 is 2018. Now we can write this 2016 as 4 into 504, right? And this plus 2 as it is, right? Now we have this congruence relation. So just take power 504 on both the sides. We get 97 raised to 4 raised to 504 is congruent to 1 raised to 504 mod 10. ठीक है, now this gives us 97. This 4 into 504 is same as 216, and which is congruent to, now 1 raised to any power is just 1. So this is mod 10, right? Now still we want 2018, right? So you just multiply this number, multiply this congruence relation by 97 the whole square. So this is just equal to 97. So 97 raised to 2 into this 97 raised to 2 into 1 is same as 97 square. Now this 97 raised to 2 and 97 raised to 2016 is just, now a raised to b a raised to, suppose p, plus a raised to q is same as a raised to p plus q, right? By the laws of indices. So this is just same as 2 plus 2016 is 2018, right? Which is congruent to 97 the whole square into sorry, this is mod 10, right? Now just note that we want this number, right? But this is a big number. We can take modulo 10 of this number and we will get the digit we wanted, right? Because here we have 97 raised to 2018. So just reduce this number modulo 10, So for this 97 square is just same as 97 into 97, right? Now when you take modulo 10, this is just 7, right? This is just 7 because you can write this 97 is equal to 9 into 10 plus 7, right? But in modulo 10, 10 is equivalent to 0, or you just cancels the multiple of 10, and the remaining, whatever the remaining number, it is equal to 7, or 97 is congruent to 7 mod 10, right? This is true, right? Because 10 divides 97 minus 7, which is 90. So when you take modulo 10 of this number, we get 7 square, right? So we have 97 square is congruent to 7 square mod 10, right? Oh, sorry. 97 square is equal to, yeah, this is 7 square. Now again this is same as 49, right? 7 square is 49. But now just note that this 49 is congruent to 9 mod 10. And the basically you just want to reduce the number modulo 10. So I'm just reducing it to mod 10, then I get the number 7 square. And then this is just 49, and then 49 is congruent to 9 mod 10, right? So by the rules of this congruences, previously we have 97 raised to 2018 is congruent to this 97 square mod 10, and we have here this 49 is congruent to 9 mod 10, ठीक है? और इसको रिड्यूस करने के बाद हमारे पास ये आया था. So we have 97 raised to 2018 is congruent to 9 mod 10. So we have this number 9 as the remainder when we divide this whole number by 10. So this remainder is the last digit of the given number, to 97 raised to 2018. So this D option is the correct option. Now let us solve the next question. The order of odd G, automorphism group of G, where this G is a group with 17 elements is. Let us first recall that this odd G consists of all the isomorphisms from G to G. That means F is a map, F is from G to G, where this G is a group, and such that this F is isomorphism. Okay. So isomorphism from a group to itself. So this is called odd G, automorphism group. So we just have to find out the order of this group, order of this. So for this, that means it is just same as number of isomorphisms from G to G. Okay. So just look at the isomorphism. ठीक है, अब क्या दिया है? G is a group with 17 elements. So order of G is 17, right? 17 is a prime, so this implies G is cyclic because every group of prime order is cyclic. ठीक है, 17 is prime, so this is cyclic. Now if you look at any isomorphism from G to G, whenever this G is cyclic, then you just map generator to generator. ठीक है, तो this isomorphism is just depend on the generator. So it is just you take the choices for generator, you will get the number of isomorphisms. So this is just same as you just find out the number of generators. Now this is cyclic group of order 17. So and it is P na, so a prime. So this gives us this phi of P, which is equal to phi of 17 are the number of generators. Now phi of 17 is just equal to 17 minus 1 is 16. So there are 16 generators, and hence there are 16 isomorphisms from the group G to itself. That means the cardinality of this odd G is equal to 16. Hence this B option is the correct option. Now let us solve the next question. In this ZX, the ring, this ideal generated by single element X is, it is maximal but not prime, then prime but not maximal, then both prime and maximal, then neither prime nor maximal. So for this, this is very simple, and you just remember one result, then you can easily solve this kind of questions. So here just note that whenever we have R is a commutative ring with unity, then in this ring these two results follows. This R by I, where this I is the ideal of R, is filled if and only if this ideal I is maximal. ठीक है, this I is maximal, and R by I is an integral domain if and only if this I is a prime ideal. ठीक है, इतना ही रिजल्ट याद रखो, आपको ऐसे टाइप के सारे क्वेश्चन सॉल्व करने को आएंगे. सो हियर दिस R is our ZX, right? And this ideal is just the ideal generated by X. Now look at R by I. So this is just equal to ZX by the ideal generated by X. Now you just use the common trick. You just cancel this X with this X. So this is just isomorphic with Z. ठीक है, अब क्या करना है? This Z is an integral domain. Yes, this is an integral domain, and hence this implies this ideal is prime. ठीक है, अभी देखा ना हमने, अगर ये इंटीग्रल डोमेन है तो आइडियल इज प्राइम इफ एंड ओनली इफ. ठीक है, अब देखो दिस Z इज नॉट अ फील्ड, है ना. फील्ड क्यों नहीं है? क्योंकि अगर आपने सपोज 2 लिया बिलोंग्स टू Z, इसके लिए इन्वर्स एग्जिस्ट होता है क्या? मल्टीप्लिकेटिव इन्वर्स? क्लियरली नॉट, है ना. क्योंकि अगर आपने ऐसे इन्वर्स लिया 1/2 बिकॉज आइडेंटिटी इज 1, तो क्या होगा? हमें 1/2 इज ए इन्वर्स, बट दिस 1/2 इज नॉट इन Z, है ना. सो द इन्वर्स डज नॉट एग्जिस्ट फॉर 2. बट फील्ड का डेफिनेशन क्या है कि एवरी नॉन जीरो एलिमेंट इज हैज़ मल्टीप्लिकेटिव इन्वर्स. ठीक है, तो इसको तो नहीं है, दैट मीन्स इट इज़ नॉट अ फील्ड. अगर ये फील्ड नहीं है, सो दैट मीन्स दिस आइडियल इज नॉट मैक्सिमल, है ना. अभी हमने देखा कि अगर वो फील्ड है देन इट इज़ मैक्सिमल एंड इफ एंड ओनली इफ. तो अगर फील्ड नहीं है तो मैक्सिमल भी नहीं है. तो हमें क्या मिल गया? दिस आइडियल इज प्राइम एंड नॉट मैक्सिमल. सो लुक एट द ऑप्शन, दिस आइडियल इज प्राइम बट नॉट मैक्सिमल. So this B option is the correct option. Now let us solve the next question. There exists a finite field of order. अब क्या बोला है आपको कि ऐसी कोई फील्ड एग्जिस्ट होती है क्या विच इज़ अ फाइनाइट फील्ड ऑफ द ऑप्शंस आर गिवन. 6 की ऑर्डर होती है, ऑर्डर 6 की होती है क्या, 12 की होती है क्या, 16 या फिर 24 की होती है क्या. यू जस्ट रिमेंबर वन सिंपल रिजल्ट विच सेज दैट अगर आपके पास कोई भी फील्ड है f, देन उसका ऑर्डर इज ऑलवेज सेम एज p रेज टू n, वेयर दिस p इज अ प्राइम नंबर. ठीक है, तो फील्ड की हमेशा ऑर्डर सम पावर ऑफ अ प्राइम होती है. ठीक है, पावर ऑफ अ प्राइम नंबर p रेज टू n ही होती है. सो लेट अस सी वेदर दिस नंबर्स आर प्राइम power of a prime or not. So let us look at this 6. So 6 is just equal to 2 into 3. तो clearly ये single मतलब this is not equal to p raised to n for some p. ठीक है, वो जो p है वो एक ही होना चाहिए. ठीक है, यहाँ पे 2 and 3 हो रहा है ना. So clearly not. Now 12 is equal to this 2 square into 3. लेकिन यहाँ पे भी फिर से 2 प्राइम आ गए. So clearly this is not equal to p raised to n. So this is also not possible. Now 16 is just same as 2 raised 2 into 8, which is equal to 2 raised to 4, right? Yes, now we have this p is equal to 2, which is a prime number, and hence n is equal to 4. So this is p raised to n. So this is a possibility for the finite field of order 16, right? And you can just check that this 24 is not equal to p raised to n for some p prime. So this C option is the correct option. Let's solve the next question. Which one of the following statement is true? The first statement is there exists a field of order 36 but not of order 49. So clearly this is not true, because 36 is just equal to 6 square, which is equal to, now 6 is just 2 into 3, so this is 2 square into 3 square, which is clearly not p raised to n for some prime p, है ना. अभी हमने देखा था कि ऑर्डर ऑफ अ फील्ड हमेशा p raised to n ही होता है. सो there does not exist a field of order 36, but this says that there exists such field. So clearly this is not true. Now second is there exists a field of order 36. अभी हमने देखा कि there does not exist, so this is also not true. Now let us look at third. So there does not exist a field of order 36. This is right. This symbol stands for there does not exist. But now let us look at this. There does not exist a field of order 36 as well as this 49. But you can write this 49 as 7 square, right? So this is just equal to p raised to n, where this p is 7 and n is 2. राइट. सो देर एग्जिस्ट अ फील्ड ऑफ ऑर्डर 49, क्योंकि हम 49 को ऐसे लिख सकते हैं. सो देर एग्जिस्ट अ फील्ड ऑफ ऑर्डर 49 and this option says that there does not exist. So this is also not true. Hence this must be true, because all these are not true. And clearly this is true because there does not exist a field of order 36. हमने अभी देखा था फर्स्ट ऑप्शन में. So this is the correct option. I hope you like this video. Please like, share and subscribe if you find this useful. Thank you.